Hello and welcome to this section of the MATLAB tutor. Here we're going to learn how to apply math functions to matrices. And if you go back to the vector section, we had a very similar section where we learned how to apply certain math functions, built-in math functions to vectors. So we're just kind of extending that idea here. So let's go ahead and create a matrix. We'll just name it cleverly matrix. And be something like, 1, 2, 1, semicolon 1 0 1 semicolon 3 2, and for the last one we'll put like pi or something like that. Just put something different in there. So here's my matrix. You can see what it looks like. And the first thing I want to do is learn how to apply the trigonometric functions to a matrix. In general, when you apply a built-in function like sine or cosine or tangent to a matrix, it's going to just apply it element by element. So when you do this, you'll see that sine of pi, which was that last one we did, was 0. So it's just going element by element, and it's just applying sine. Now, of course, it's treating everything as if it were in radians, and it is in radians here. And if you do the cosine, then you have the same thing. Cosine of pi, this was the original matrix, is -1. So you can kind of see it's functioning. So these other numbers, 1, 2, 1, they're all treated as radians. So this is 1 radian, 2 radian, and so on. All right, so sine, cosine, tangent, secant, cosecant, all of those trigonometric functions that we've learned up till now can be applied to matrices, and they're just going to be applied element by element. So that's really easy to do. If you have a lot of data and you need to take the sine or cosine, go ahead and do that, no problem. Let me put the matrix back up on the screen, and let's apply the square root. This is a good way to illustrate something. If you apply the square root then what's going to happen is you're going to take the square root of each of the elements, right? So the square root of 1 is 1, the square root of 1 is 1, the square root of 3 is 1.7, and so on. The square root of 2 is 1.41, and so on. So basically it takes the square root element by element by element. So you need to keep in mind that whenever you apply the square root function to the matrix, it's going element by element. Now, there is a mathematical definition to take the square root of a matrix and treat it as its own unit, as its own entity. And to do that, you have another function, square root m. The m means matrix. So when you really want to take the square root of the matrix and use the mathematical definition that's defined in books, then you can use square root m and you'll get this complex answer. I need to just make sure you understand that when you apply, in general, when you apply functions like this to a matrix, it's going to go element by element. But there's another mathematical definition to take the square root of a matrix and to treat it as an entire entity there. And obviously you get a complex result like that. So if you've studied enough math to know how to take the square root of a matrix and do it in the proper mathematical way, the definition of the math way, then you'll understand what this is. Otherwise, you'll probably never use it. So going element by element, you just use the function. If you know you need to take the true definition of the square root of a matrix, then you'll need to do this guy with the m. Now let me show you real quick. If you take, the square root of any number, like the square root of 25 is 5, right? Well, then if you take 5 times 5, you should get the original number back, right? Because the square root of 25 is 5, so if you take 5 times 5, you should get the original number, which is 25 back. So if you take the square root of this matrix, notice I'm using the real definition, the true mathematical definition of the square root of a matrix, and you multiply it by itself, what should you get back? If I'm taking the square root of this matrix 2 times and I multiply it, I should get the original matrix back. And that's exactly what I get up here. I mean, it has some i's in here, but if you look, all the i's are 0. So you can just disregard them. And what's happening is you're taking this matrix here, this square root m matrix, you're getting it again, and you're actually multiplying them together. You're multiplying them together in the true matrix sense, across, down, across, down, across, down. You're doing the true matrix multiplication. The definition of the square root of something is such that whatever answer you get, if you multiply it by itself, you should get the original thing back. And that's why I say this is the true mathematical definition of the matrix, square root. When you get an answer, you should be able to multiply this matrix by itself in the true matrix multiplicative way and get the original matrix back. So that's why there's 2 functions here. This one's just element by element. This one's the real definition, so that if you multiply it by itself, you get the original guy back. All right. So let me clear the screen. We put the matrix back up there. So we've talked about square roots. We've talked about trig functions. We have the same sort of thing for exponentials when we want to take e and raise it to the power of something. If you do e to the power of a matrix, right, then MATLAB is going to go in element by element. It's going to say e to the 1, 2.71, e to the 1, 2.71, e to the 3 gives you this element. So again, when you in general, when you have a function that you're passing a matrix to in general, it's going to operate element by element and give you the answer back. Now again, much like the square root, this is not the true mathematical definition. If you really take e and raise it to the power of a matrix, there's a much more involved math that's really the true definition of the matrix, not this element by element business. And if you have a need for that, then there's a function expm. Right? This is the giving you the true answer if you take the number e and raise it to the power of a matrix, the matrix being its own entity, right? Then you will get this guy. This matrix is different from the original one because this is not element by element. This is treating the matrix as its own mathematical entity, and if you've studied that stuff, great. If you haven't, then you don't really need to worry about it too much. Let me clear the screen. Put matrix back up there. The same exact thing holds if you want to take the logarithm. If I want to take the logarithm of this matrix, just like this, then it applies it element by element. The log of 1 is 0. Log of 1 is 0. Notice over here, log of 0, basically I'm getting infinity, negative infinity. And so on. That just is because of the way the logarithm's defined. And log of pi is this. So this is again going element by element. But if you have a need to calculate the log of this matrix, not element by element, but as a mathematical entity, there's a definition for that, that mathematicians have figured out. Then you have another function called log m. That's the matrix logarithm, right? And it's giving you a warning. It's letting you know some things here about eigenvalues and stuff. It's all about the mathematical definition of how this is done. And here's the answer that it calculated that gives you the matrix logarithm, which looks totally different than this element by element business. So in general, if you're passing, like square roots, exponentials, and logarithms, if you just use the regular old command, from MATLAB that you've used before, then it's going to go element by element. In most cases, that's probably what you want. But if you're a mathematician or if you're doing something where you really want to take the matrix logarithm or the matrix exponential or the matrix square root, and you know that you want the real mathematical definition of how that's done, then you need to use those special commands. This is exactly analogous to when we did matrix multiplication. When you do matrix times matrix, this is the mathematical definition doing the mathematical multiplication across and down, across and down, across and down. That's how mathematicians have defined it. But if you want element by element, you have to specify with the dot command that you want element by element, and you get a different answer if you do it that way, because multiplying element by element is totally different than the regular definition for matrix multiplication. Similar kind of thing with some of these built-in functions. It applies them element by element if you just use the regular function, but if you want the real definition, you have to put that m at the end there. Okay, let me show you a couple more things. If you want to raise a matrix, if you want to raise a number to the power of a matrix, right, then you're going to get an answer. And if you want to do it element by element, you'll have to put the dot operator in front, like this. And let me put the original matrix up so you can see it. So when you tell MATLAB that you're taking the number 2 and raising it to the power of a matrix, if you put the dot in there, then it's going element by element. That's telling MATLAB do it element by element. 1 squared is 2, or I should say 2 to the power of 1 is 2. 2 to the power of 1 is 2. 2 to the power of 3 is 8. 2 to the power of 2 is 4, and so on. So it's taking each element of the original matrix, raising 2 to the power of this element, and then it puts it in the final answer. This definition up here is, again, just like we talked about before, this is the true mathematical definition when you take the number 2 and you raise it to this entity that we call a matrix. It's not element by element. There's a mathematical definition to take numbers and raise them to a power that's a matrix. If you've never studied this, then don't worry about it. But I'm just showing you that there's a difference here. If you get something that doesn't look right, you need to make sure, and you're expecting to go element by element, you need to tell MATLAB to do that. Let me clear that out, put matrix up here. The same thing happens if you want to raise this matrix to a power. You know, a lot of students will do something like this, matrix to the power of 3, right? And they want to get an answer, and then they're like, this makes no sense. 1 to the power of 3 is not 28. 2 to the power of 3 is not 24. This is because this definition here, when you start using this guy, is the true mathematical definition of taking a matrix and raising it to a number. There's a mathematical definition for how you do that, just like there is for when you multiply matrices. If you want MATLAB to do it element by element, you need to tell it that you have to do element by element by doing this. Now you get what you expect. 1 to the power of 3 is 1, 3 to the power of 3 is 27, 2 to the power of 3 is 8, and so on. So that's basically that. You know, it's one of those things that occasionally you'll have matrices, you're trying to manipulate them, you get crazy answers, and you're like, what is MATLAB doing? MATLAB's crazy. But really, it's following the real definitions of how you do this stuff. But sometimes you have to force MATLAB to tell it what to do, what you want to do, depending on what your application actually is. So play with this, create a little matrix, take some powers, take some logarithms, take some trigonometric results with them, and just make sure you understand the difference in how it's applying these functions to matrices.